I'm Jeff Zarnett, and this is Software Career Growth. Today, we're talking about writing good incident reports. So, about incident reports. The obvious question is, what does an incident report have to do with career growth? Well, incident reports are about learning. The idea is that you should learn some lessons from what went wrong and be able to prevent those things from happening again in the future. And that sounds like learning, that sounds like growth to me. If you want to make engineering a better organization, if you want to take some important lessons forward that you know for the future, then, well, writing an incident report or reading and understanding a good incident report is an important part of that process, because these things are pretty memorable, right? I mean, I can tell you every time I caused a major production outage, I remember the incident pretty well. It was a learning experience for me, and you will no doubt have some of those depending on your career and the impact that you have. Some of them may be minor, some of them may be major, some of them may be critical and disastrous and like, oh no. Hopefully not, but ideally you will learn something, and you will be a better engineer as a result of what you've learned. So let's talk about incident reports and what's going on. Sometimes they're called a post-mortem. You can sort of call them whatever you want, but it's an opportunity to try to identify the root causes of an issue and learn whatever lessons. If we don't find the root cause, the incident could happen again. And if we don't learn those lessons and address the root cause, then the same problem will recur. So an incident report needs to have a breakdown of what happened, ideally with a clear timeline of events, with the goal to understand when the problem started, when it was noticed, what actions were taken, and when the incident was resolved. So strictly the facts here, no speculation, no analysis, anything like that. The facts of the case should explain sort of what's going on and how we got from A to B to C here. The most important part of the analysis, if you ask me, is why the incident happened. And when we talk about why, we're talking about causation, causes, what is the thing that led for this to occur. And there's two kinds of causes, root causes and proximate causes. Proximate causes are the things that happen just before the problem, or are the trigger that makes the problem noticeable. If you remember talking about, say, deadlock, a deadlock can occur because thread A acquires lock X and then waits for lock Y, whereas thread B acquires Y and then waits for X. The proximate cause is the lock acquisitions of threads A and B, such as because user 1 is trying to update a record while user 2 is trying to run a report, and they have data elements in common. But that's not the root cause. The root cause is actually we don't always acquire locks in a consistent order. And if you remember, one of the ways that we can prevent deadlocks is actually prevent acquisition of locks out of order. If we always follow a consistent order, then we have a problem. And finding things like that, the root cause, as opposed to just sort of stopping at a superficial level, is really important to making sure that the problem is solved for good. If we just say the root cause is, I wrote code that contained a bug, well, the solutions to that are just don't do that. Write more tests. Try harder. Those are part of the solution, but they don't go far enough, right? We need to think about root causes like the test environment is unrepresentative of the production environment, so it's hard to assess the actual impact of a change before it goes live. Or maybe the root cause is we just don't have enough knowledge about the subject of concurrency, and if we'd known about this lock acquisition order thing, this whole thing could have been prevented. So how deep do you need to go in this, right? Toyota, and I mean the car company, Toyota, uses a model that they describe as 5 whys, which is to say you should ask the question why 5 times to make sure that you get to the actual root cause. I don't think it's necessary to always use exactly 5. That's a little bit prescriptive. The real cause may be uncovered in 3 whys or 6, but it's a guide to making sure that we're asking at the right level. If we don't ask the question enough, our answers end up really superficial with this idea of just don't write any more bugs, write more tests, which factually correct, but not really a root cause solution. But also, if you ask the why thing too many times, you end up with a root cause that says writing code is hard, and we end up debating whether computers were a mistake. I know some people who would definitely take the yes side of that argument. And ultimately, although that's an interesting philosophical discussion to have, it's not very practical in terms of how am I going to stop the concurrency issues that lead to a deadlock from recurring in the context of the application program that I'm working on. So we've got to be at least a little bit judicious about how many times we ask why. And then there are action items. Given that we've identified the root cause, what are we going to do about it? And action items are both short and long-term things to prevent the problem. So short-term things, fix the bug, add more monitoring or alerting. Maybe we need to do some cleanup because some customers' data was corrupted as a result of the incident and we need to fix that. Those are all short-term items. Ideally, we can think of something that would prevent this kind of problem from happening again in the first place. Maybe you want to introduce a test bench deployment stage that catches performance problems before they go to production. That means when a commit is pushed, just as you would do your unit tests and your integration tests and anything else in your build steps, you also have a performance test. And okay, if the time to complete the test data set has gone up, say more than 5%, you might say that's a problem and you might fail the tests, and you'll figure out then and there what's going on. Action items obviously only help if you do them, so they have to be realistic. I gave the example of a concurrency problem. You could say, well, what if we could prevent all race conditions by rewriting all code in Rust? Factually correct, but it's also unlikely to happen. Right? Your code base is likely large, there's probably a lot going on. Rewriting it would be an incredible effort and probably not well justified, all considered, with the cost-benefit analysis. But you might say, well, okay, what if we did more training on the subject of concurrency? What if we introduced testing using tools designed to look for concurrency problems? For example, the Helgrin tool in the Valgrind suite could potentially identify lock ordering problems, which would help you to solve that kind of issue. My view is tools are good, training is better, but of course someone who's here focusing on software career growth, talking to people, would say so. Tools are still an important piece of the puzzle, but if people are aware of the potential for a problem, they foresee things, whereas a tool like Helgrind could only catch the problem when it's observed during an execution run of your program. And as I would say, if you have some code that only runs, say, on the last day of the year, unless your test environment sets it up to run this code as if it is the last day of the year, you might not observe the problem that actually takes place there. And then once you've identified the root cause, you've come up with some action items, the final things are about lessons learned. Lessons learned don't necessarily have to be head-exploding revelations, but there should be at least a few takeaways. Not every learning has to be bad. It's entirely possible that you could say the conclusion is the monitoring system is very effective, it caught the problem quickly, we're glad that this happened, and that's good, right? We want to have all these sorts of things recorded, and we want to identify what is working well and we should do more of, as well as what is not working well and what we should be changing. Lastly, there are a few things that really should not be in the report. Number one, irrelevant detail. Irrelevant detail is super easy to explain. Imagine that you were asked to read a document and the document contained a whole bunch of junk and you were just not interested in any of that and it was hard to find out the relevant parts of it. Of course, you would dread reading it. You wouldn't want to. You would ask somebody to make a summary. That kind of thing is just a waste of time. The less likely it is to be read, the less likely it is anyone will take action on it. Number two, speculation should be avoided. Speculation is frequently wrong. Sometimes we might be forced to proceed without being totally sure about what happened or why, but educated guessing and theorizing are allowed where absolutely necessary. But speculation is just guessing without any basis. Finally, the report should not contain any blaming or shaming because these are counterproductive for learning and changes. Why is blaming bad? I mean, if you know you're going to get in trouble because an incident occurred, that really incentivizes covering up incidents or denying the problem as opposed to recognizing that a problem has occurred, or declaring an incident, doing something about it. It also incentivizes people to spend time shifting blame to others or arguing about who is really at fault. And again, those are counterproductive to solving the problem, because the effort that's spent arguing about whether Team A or Team B is responsible for this bug is time that could be spent addressing the bugs or preventing the future ones that are similar. There are lots of articles out there that are admittedly about, say, patient outcomes in a medical setting that say that blaming culture, where we're trying to identify who is responsible and assign them the blame, is much less effective in terms of providing good patient outcomes when compared to a learning culture where it's intended as blameless and it's intended to be focused on what produces the best outcome for the patients, not worrying about who's responsible for what and arguing about what's going on here. So blaming and shaming is bad, and anything you can do that makes people sort of feel safe in sharing what happened and be honest about what happened is only to your benefit. With that said, not every organization is going to be as good at this as every other. Lots of companies say, oh, we have a no-blame culture and we don't get upset when things go wrong, we just focus on fixing the problem. You'll have to see for yourself if that is really the case. I always tell a story about one place that I worked where I was told that was the case, but I didn't really believe the no-blame thing until I actually caused a major production outage where major functionality didn't work overnight, and the reaction of people and the understanding and compassion and focus on solving the problem and preventing it again in the future really convinced me that they meant it. It wasn't just empty words. So those are my thoughts on the subject of how to write an incident report and what should be in it and how it should look. I hope you find that helpful. Ideally, there are few incidents, so you don't need this very often. But ultimately, things will go wrong, and an incident report is one of the ways that you can turn something bad into something good. That's it for this video. Thanks for watching. Don't forget to like and subscribe.